We saw some chemical properties of organic compounds. Now we have studied in general about the organic compounds. Now let us see some 2 or 3 types of organic compounds and study about them in detail. So we are going to study about 2 organic compounds which are commonly used. One is ethanol and one is ethyl alcohol, that is ethanol is also called ethyl alcohol, and the other one is ethanoic acid. So first we will talk about ethanol. Now ethanol is also called as ethyl alcohol. When we were doing the functional group OH, that is the alcohol group, I had told you that ethanol and ethyl alcohol is same. That means the common name is ethanol, the chemical name is ethyl alcohol. What is the formula? The formula was CH3CH2OH. Now this formula can be called as condensed formula or C2H5OH. That is the molecular formula. Ethanol or ethyl alcohol, the formula is C2H5OH, or that is the molecular formula, and the condensed formula is CH3CH2OH. This condensed formula is also called as linear formula. So if in exam you are asked to draw the condensed formula or the linear formula, you have to show the arrangement of hydrogen with carbon and OH group. Now how to make structure of this ethyl alcohol? How many C's are there? There are 2 C's. So draw 2 C's. Now we have to arrange with the first C 3 hydrogen. So 1, 2, 3. So you can just arrange 3 hydrogen like this. Then see how many hydrogens are attached to the second one. Here 1 and here 2. Now OH group can be shown like this. Now I have drawn it. You can write OH group continuously also, that is also correct. But if you want to show the formation of bond between O and H, we have to show a line like this. Because oxygen is an element or the atom which contains 2 electrons to complete the octet. So oxygen is getting 1 electron from carbon and 1 electron from hydrogen. So this is the structure of ethyl alcohol. Now if I know the structures, what are the properties of ethyl alcohol? Let's see what are the properties of ethyl alcohol. Now the first property which we see is it is a colorless liquid. There is no color, colorless liquid. It has a pleasant smell. It is not bad smelling, but it has a pleasant smell. It is a combustible liquid. What is a combustible liquid? A liquid which can burn very easily. So it is combustible liquid, or it is combustible, and it burns with a blue flame. The fourth property which we can identify is its boiling point. Its boiling point is 78 degrees Celsius and its freezing point is equal to -114 degrees Celsius. That means alcohol freezes below 0 degrees, that is -114 degrees Celsius, and it's boiling. If we want to boil alcohol, we need 78 degrees Celsius temperature. These were the properties of ethyl alcohol. Now how does ethyl alcohol show the chemical reactions with certain things? We are going to see 2 chemical reactions. First we are going to see how it reacts with sodium metal, and second we are going to see how it is reacting with phosphorus trichloride. So let's see chemical reactions of ethanol. Now ethanol or alcohol, which we call as C2H5OH, if I allow it to react with sodium metal, what will be the reaction? Let's see. C2H5OH plus Na. Na is sodium. Now here this sodium will replace H from alcohol and it will form sodium ethoxide, C2H5O Na plus hydrogen. So sodium ether oxide. So this is the product form, sodium ether oxide plus hydrogen gas which evolves. Now let's balance it. 2, 2 and 2. We tried to balance oxygen here and here oxygen, and this is how the balancing is done. C you can see 2 into 2 is 4, 2 into 2 is 4, H 5 plus 1 6, 6 2s are 12, here 5 2s are 10, plus 2 12, oxygen 2, oxygen 2, sodium 2, sodium 2. So this is how the ethyl alcohol reacts with sodium metal. This was the first reaction. Action with, second type of reaction is action with PCl3. Now what is this PCl3? It is phosphorus chloride, phosphorus trichloride. So phosphorus trichloride. Now what is happening? Let's see. C2H5OH plus PCl3. Now this reacts, this whole OH group is replaced by chlorine. So here C2H5Cl will be formed and along with it phosphorus acid. See how it is, C2H5Cl plus H3PO3. Now this is the reaction which is followed. This is called ethyl chloride and this is called phosphorus acid. What is formed? Ethyl chloride and phosphorus acid. These are the two reactions which are generally commonly used with alcohol. First one was alcohol reacting with sodium. It forms sodium ether oxide and hydrogen which is released. Secondly, alcohol reacts with PCl3, that is phosphorus trichloride, and it forms a product ethyl chloride. Now this Cl is replacing whole group of OH ion and this is replacing it with the chlorine, and this C2H5OH becomes C2H5Cl plus H3PO3, that is phosphorus acid. The next organic compound which we are going to find out about its properties, how it reacts, is ethanoic acid. What is ethanoic acid commonly known as? I told you that we use it in everyday life also. We use it as a preservative also. Yes, it is also called as vinegar. This vinegar or ethanoic acid is also known as acetic acid. So we have next one, ethanoic acid, also called acetic acid or vinegar. Vinegar is diluted form. Now this acetic acid or ethanoic acid, what can be its formula? We have learned about the carboxylic group as a functional group. That is functional group, it is attached in this. That means the functional group COOH is forming the ethanoic acid. Now here the root name is eth and oic is the carboxylic group. So we can say the formula is CH3COOH. Now this COOH is the functional group which is carboxylic acid. Now if I want to ask you what is the molecular formula, so what will you say? You will just say how many C's are there? There are 2 C's. So you will say C2. How many H are there? 4. So C2H4. How many O's are there? O2. So this is the general formula or the molecular formula, but this is the linear formula or condensed formula. This is the formula of ethanoic acid, CH3COOH. Now we all know where it is used. What are the properties of ethanoic acid? How will you identify that it is ethanoic acid? It is also a colorless liquid. First, like an ethanol, ethanoic acid is also colorless liquid. But what about its smell? Have you ever opened the vinegar bottle? You must be smelling a very bad pungent smell. Yes, that's the smell which identifies it. If I give you 2 test tubes, one of ethanol and one of ethanoic acid, and ask you to smell and identify. So the smell of ethanoic acid or vinegar is so pungent that if you try to bring the test tube near, you may not be able to breathe. Such a bad smell it is. So the second is it is having a pungent smell. Concentrated form of this ethanoic acid is very corrosive. It is very corrosive in nature, so you can say that it is corrosive liquid. This ethanoic acid is highly soluble in water. You add any amount of water or any amount of ethanoic acid in water, it easily gets soluble. So the fourth property you can say is highly soluble in water. These are the properties which can identify that it is a ethanoic acid. Now ethanoic acid has a one specialty. If I bring the temperature below 290 Kelvin, it starts to freeze, and that freezing is called as the freezed ethanoic acid or freezed glacial acetic acid. This is the name which is given. So below 290 degree, below 290 Kelvin, it freezes, and therefore it is called glacial acetic acid. Now we saw the properties of acetic acid or ethanoic acid. Where is acetic acid used? Let's see some common uses. Now common uses, it is used as a food preservative. If you have seen ketchup being made, jams being made, acetic acid is used or vinegar is used in a small quantity, and that is added as a food preservative which is not allowing the microorganisms to grow on it. So the shelf life of those jams and sauce or the ketchup is increasing. Secondly, it is used in making perfumes. Now perfumes are all sweet smelling or nice smell is coming from perfumes. Then how acetic acid is used in making these perfumes? We have learned about alcohol. Now when this alcohol and when this acetic acid reacts together, they form a product which is called as ester. Now ester is a sweet smelling or having a nice smell, and therefore it is used in making perfumes. We are going to learn about how to make ester in the chemical properties. Third, it is helping in, or it helps in coagulating rubber from latex. What does this line means? We are getting rubber from the rubber tree. If you have heard or if you have seen in any documentaries, you will see that if I scrape the outer part of rubber plant, the rubber slowly trickles down. Now that rubber is in the liquid form. That is called as actually the latex. Now it is processed, and that processing of latex to make rubber is done with the help of ethanoic acid. So this is how, these are some uses which we can see in our surroundings, and these uses make them an important part in our food industry also. Now we saw the properties and uses of acetic acid or ethanoic acid. Now how does it react chemically? We are going to see basically three types of reaction. I'll show you how. First, we are going to see reaction with halogens. Now what are halogens? Halogens are a group which contains bromine, chlorine, iodine, fluorine. These are all called as halogens. So I can write in the bracket fluorine, chlorine, bromine and iodine. F stands for fluorine, Cl stands for chlorine, Br that stands for bromine, and I stands for iodine. So when we talk about reaction with halogens, we are going to see how it reacts with halogens. Second reaction which we are going to see is reaction with metals. Now again we are going to see here the reaction with sodium. We will compare the sodium reaction with alcohol and the sodium reaction with acetic acid. And third reaction which we are going to see is esterification. Now esterification means reaction with alcohol. These three major chemical reactions we are going to cover in this part. Now let's start with the first one, reaction with halogens. As I said, halogens are of various types: fluorine, chlorine, bromine, iodine. So most common which we generally use is chlorine. So let's see how it reacts. CH3 COOH. Okay, this is the acetic acid. If I react it with chlorine, what will be formed? Now here one hydrogen atom of CH3 group will be replaced with one atom of chlorine. That means one chlorine will replace one hydrogen. So what will be the formula? CH2Cl COOH. This will be the formula which is formed of the product. So one chlorine is replacing one hydrogen and it is forming CH2Cl COOH. What we will name it as? Monochloro. Mono means one. So one chloro acetic acid, because rest is all acetic acid. So monochloro acetic acid. Write down monochloro acetic acid. This is the reaction with chlorine. Now if I go on reacting with chlorine, what will happen? Let's take this monochloro acetic acid reacts continuously with chlorine. Now what will happen? Let's see. CH2Cl COOH plus chlorine again. Now this hydrogen, out of these two hydrogen, again one will be replaced by chlorine. So what formula will be formed? We are left with CHCl2 COOH. CHCl2 COOH. Now what has happened? One chlorine has replaced one hydrogen and therefore one hydrogen only is remaining. So it forms CHCl2 COOH. Now what is remaining? Here one H was remaining, one Cl was remaining. So we have to show one HCl here, one HCl here. Now what will be the name of this product? Here how we named it? because there was one chlorine in the acetic acid. So monochloro we said. Now here how many chlorine is there? There are 2 chlorine atoms. So what we can say? Dichloroacetic acid. Right, dichloroacetic acid. Along with it, hydrochloric acid is formed, because that is what is left. Here one Cl will be left, here one H is removed. So that H and Cl reacts to from HCl. Here also one H will be removed, one Cl will be left. So that H and one Cl will form HCl. If I continue reacting, let's take this dichloroacetic acid, CHCl2 COOH, again reacts with chlorine. This one H which is remaining, this will also be replaced by chlorine and H will be removed. Now what will be formed? CCl3 COOH plus HCl. Now we have named these two. How we will name this here? Now here how many chlorine are there? 3. So instead of di it will become trichloroacetic acid. And what is formed along with it? Hydrochloric acid. This is the reaction of acetic acid with halogens. Now if I take bromine also, instead of Cl you will be only writing Br. If I take I, that means iodine, instead of Cl here you will be writing I. So it depends on which halogen you are taking. We have taken a simplest example of chlorine. I'll try to explain you once more. Acetic acid reacts with chlorine. Now this chlorine atom, this molecule of chlorine has 2 atoms. So what will happen? One atom will replace one hydrogen. So we are left with CH2, because now one hydrogen has gone, and then Cl is getting attached here, COOH. So naming also becomes easy. How many Cl's are there? 1. In chemistry we say mono, di, tri, tetra. So mono means 1. So monochloroacetic acid. Now this monochloroacetic acid, if it continuously goes on reacting with chlorine again, so another hydrogen will be replaced by this chlorine atom. So we are left with CHCl2 COH. Now here 2 Cl's are there. So instead of mono you will write di. So dichloroacetic acid. Now if this dichloroacetic acid is continuously reacting with chlorine, so this lone one only hydrogen is left, that hydrogen will be replaced by chlorine. So instead of di, now tri, because we can see here 3 chlorine. So trichloroacetic acid is formed along with hydrochloric acid. This was the reaction with halogens. Next we are going to see how the acetic acid or the ethanoic acid reacts with metals. Now here we are going to take again the sodium metal to make you understand better how the reaction of ethanoic acid takes place with sodium. Let's write CH3COOH plus Na. Now what will happen? Na will take the place of hydrogen. This Na is going to replace hydrogen and it is going to form sodium acetate. That means CH3COONA. It is called as sodium acetate. Now what is left here? Hydrogen. So it will form hydrogen which is evolved out. This is a reaction with sodium. So acetic acid plus sodium. This sodium takes the place of hydrogen and hydrogen is removed. Once hydrogen is removed, it forms a product which is known as sodium acetate, because it was named as acetic acid. So acetic acid, instead of acid, it has become acetate. So sodium acetate, that is CH3COONA plus H2. H2 is evolved. Now if I ask you, can I use a test where pop sound test is used for hydrogen? In this case, you may not get a pop sound because the amount of hydrogen released is not enough to burn. we generally see with very strong acids and sodium, we get a pop sound. But here you may or may not get, depends on upon the amount of hydrogen which is evolved. Now third reaction, that is called esterification. Esterification is a reaction between alcohol plus acetic acid. This reaction is called as esterification reaction. Now let's see, alcohol plus acetic acid. Now we are learning with acetic acid. Let's write first CH3COOH. This is acetic acid. It reacts with alcohol C2H5OH. We learned about alcohol. Now we are learning about ethanoic acid or acetic acid. Let's see how these two can react. Now these two react, what happens? This hydrogen and this OH group separates. Now when it separates, obviously H and O, that means it is going to form water. But what about the main product? Main product form is not whatever is left, you have to write CH3 COO, CH3COO, C2H5 plus H2O. This product is formed, which is called as ester, and it is a sweet smelling liquid. This is ester which is formed, which is the sweet smelling liquid, and it is also known as ethyl acetate. This product is an ester which is also called as ethyl acetate. This esterification reaction is used for making perfumes. As I said, it is also used for making the essence which we are using in the food. In the baking industry, use large amount of essence to give a different flavors, and that flavors come from the production of ester. Now this ester is present in the fruits also. How? These natural esters are present. Here we are synthesizing, or we are making it, but natural esters are also present. When you cut an apple, you get a different peculiar smell. When you cut a mango, you get a different smell. Even if you are closing your eyes and you are asked to identify which fruit I am cutting, you can easily identify. Now why is it easy to identify a fruit without looking also? By its smell. And that smell is coming because those fruits are having natural esters in them. So pineapple if I cut, I get a different flavor. Mango if I cut, I get a different flavor. That means different types of natural esters are present in fruits. Same way here, synthetically we have reacted the alcohol with ethanoic acid, making an ester which is used for making perfumes and other sweet smelling liquids. Now we learned about ethanoic acid. If I give you a test tube filled with a colorless liquid and another test tube also filled with a colorless liquid, and I tell you one is alcohol, one is acetic acid, and mind you I am giving a very dilute solution so that you don't get that pungent smell also. How will you test it? How will you test whether it is ethanoic acid or not? I want you to tell me which sample is ethanoic acid. So very easy test we have. Test for ethanoic acid. First test is litmus test. Now what is litmus? Litmus is an indicator. Litmus, red litmus and blue litmus we use in the laboratory. We can use the liquid form of litmus, we can use the litmus strips also. So if I use litmus test, what I am doing, I am taking a drop of this, any solution which is given, and dropping it on the red litmus paper and blue litmus paper. where will I see a change in color? Now, ethanoic acid, as I said, it is an acid. It's a mild acid. That means the acid always turns blue litmus paper to red. So, in this case, there will be no change in color. And here, the blue color will change to red. This is one of the way to test whether the solution is acetic acid or not. If the sample given to you is asked whether this sample is ethanoic acid or not, the second type of test which we can see is esterification. I take the sample which is considered to be an acid and I react with alcohol. If I get a sweet smelling liquid, then I will say the sample which was given to me contains ethanoic acid. This is the second test which can identify that sample is a ethanoic acid. Third, let it react with carbon dioxide. Reaction with sodium carbonate. I said carbon dioxide test, but when will be the carbon dioxide coming out? When I react it with sodium carbonate. So, if I react ethanoic acid with sodium carbonate, I get a large amount of effervescence. Now, what is effervescence? Too many bubbles come out with evolution of gas, and that gas which is coming out is carbon dioxide, and this carbon dioxide can be tested with lime water. If I send this carbon dioxide in lime water, the lime water turns milky. Proving that the reaction of sodium carbonate with the sample which was given was ethanoic acid, because ethanoic acid reacts with sodium carbonate, ethanol does not react with sodium carbonate, and it produces carbon dioxide which in turn turns lime water milky. These are the simple three tests which can identify a sample given to us whether it is a ethanoic acid or not.